Okay, today we're talking about power. The equation for power is power equals work over time. The units for power are watts. So in this case, how much energy is being used by the light bulb after this many seconds? Well, if power equals work over time, and we know our power, it's 100 watts, which means 100 joules per second, then we can go with 100 equals the work, or the energy, divided by the time, which is 5089. So we multiply both sides by 5089, and calculator says, I don't know why I'm using a calculator, I just add 2 zeros on the end, but whatever. The answer to A is 508,900 joules. Okay, how long? So now I take my power equals work over time, but I'm solving for t. So I can take my power, which is 100, equals 5385 joules over t. Multiply both sides by t, divide both sides by 100, and I get 53.85 seconds. So in less than a minute, you've already used that many joules of energy. Okay? You and your friend decide to hike Y Mountain. Y Mountain Trail goes up that many meters. It only takes 49 minutes to reach the Y, but your friend takes 100 minutes to reach the Y. Your mass is 85 and your friend's mass is 100. Okay, so power is work over time, right? So work is change in energy. You can read that, change in energy, which means what energy is changing if you go up a mountain? It's your gravitational energy that's changing. And since you have zero energy to begin with and gravitational energy at the end, then your power is just gravitational energy over time. Or in other words, your power is just mgh over time. So, in the first case, for you, your mass is 85, G is 10, H is 335.9, and the time is 49 minutes times 60, because we've got to convert it into seconds. Right? The standard unit for time's got to be in seconds. So, getting my calculator out, we've got 85 times 10 times 335.9 divided by parentheses 49 times 60 end parentheses, and we get a grand total of 97.11 watts. Okay. Your friend is going to be the same equation, except he is 100 kilograms times 10 times 335.9, all divided by 100 times 60. So 100 times 10 times 335.9 divided by 100 divided by 60. Okay, so your friend has 55.98 watts. Okay? So, Holke can lift this much mass up this far in this many seconds. Bulky can lift this much mass the same height in 12 seconds. So again, when you're lifting something up, the energy that is changing is your gravitational energy. And since you start with zero gravitational energy and you end with a bunch of gravitational energy, then your power, which is change in energy over time, becomes power is mgh over time. So, for Hulky, he's lifting up 76 times 10 times 1.26 divided by 4.5. Okay, 212.8 watts. Bulky is lifting 117 times 1.26 times 10, I forgot that one, divided by 12 seconds. So he's got 122.85 watts. Okay? So it's pretty straightforward. The biggest thing that people have trouble with is remembering that, power is change in energy over time, which is the same thing as your final energy minus your initial energy over time. But in a lot of cases, your initial energy is 0, right? And so you have to ask, well, what kind of final energy are we dealing with? If it's high, then it's gravitational. If it's fast, then it's kinetic. If it's springy, then it's spring, right? And so deciding what type of energy you end with and the difference between those energies, and then just taking that divided by time. That's going to be your power equation. Okay, good luck.